Hi, it's Miss Tolmich, and today's video is about speed and velocity calculations. I first want to start talking about the lab that you did last week. You were asked to walk a distance and time it, and then make a graph from that information. We then asked you to calculate the slope of the lines that you graphed. Well, looking at the slope formula, m equals y2 minus y1 divided by x2 minus x1. Looking at that, m is the slope, and what is on the y's? That's your distance. So your distance is what was represented on the y-axis. What is represented on your x-axis? That's your time. And when you calculated this, you were actually calculating your speed. Distance is measured in meters and time is measured in seconds. And so you were calculating your speed in meters per second. It might help to think about speed in everyday life being miles per hour. Miles is a distance and hours is a measure of time. So any speed that we talk about is always going to be a distance divided by a time. Looking at the two graphs, you should be able to see very quickly that, no pun intended, this is the graph that the person walked faster. How do you know? The slope of this line is steeper, which means if it's steeper, it's going to have a higher slope, right? The value of this slope should be higher. The magnitude of this slope should be higher. And since the slope is higher, that means it's a faster speed. These two formulas look very similar. They are both d divided by t and d divided by t. However, this says S average and this is V average. The S is for average speed. The average speed is the distance traveled divided by the time interval during which the movement occurred. That is a very precise way to say how fast are you moving. How much distance are you covering and how long did it take you to cover that distance? Now, velocity is virtually the same definition. The displacement divided by the time interval during which the displacement occurred. Again, in everyday language, it's how fast you are moving and in what direction you are moving. Let's define what these letters mean, okay? The D could stand for distance or displacement. They are both measured in meters. But remember the scalar vector information you've been given? Scalar is a quantity that only has a magnitude. It just tells you a number. A vector quantity tells you how big something is, that's the magnitude, and it tells you a direction. So, for example, a distance would be, say, 5 meters. A displacement would be 5 meters north, okay? This is a scalar quantity and displacement is a vector quantity, okay? Time, there's no direction in time. It's scalar, but we measure time in seconds. Speed and velocity mean sort of the same thing, but in physics, we like to be very, very precise. Well, hopefully, you can tell the difference. Speed is just how fast you're going, okay? You're going 5 meters per second, you're going 55 miles per hour. It's just the magnitude. Velocity is more precise. It's how fast plus the direction you're going in. So this would be 5 meters per second forward, 5 meters per second east, or 55 miles an hour southeast. Again, this is scalar, this is vector. Let's look at the formulas again. While they both are d over t, I hope you realize now that this is distance because speed and distance are both scalar quantities, and this d stands for displacement because velocity and displacement are both vector quantities. Let's do a calculation. A car travels 54 meters in 8.5 seconds. How fast was it traveling? And are we solving for velocity or speed? Now, I know many people, they see a question like this, and if it was multiple choice, many of you would just make a guess. We don't want you guessing on these answers. Well, not the typical guessing. There's multiple ways to solve for this, but the most basic way and a way that will always help you is write down your givens, your unknowns, then write down the equation, substitute what you know into the equation, and solve. So this is the good way to guess to get the answer. So let's start with our givens. 54 meters. What is that? Thinking about the variables that you know, I know that that is a d, but let's figure out if it's distance or displacement. Do we have a direction? No. So this d stands for distance, but we're just going to leave it as the d. 8.5 seconds. Hopefully you realize that anything that is measured in seconds is a time. Now, our unknown is either going to be velocity or speed. It says how fast was it traveling, and both velocity and speed have how fast as part of them. But to have velocity, we would need a direction. And does it tell us which way it's traveling? Does it say northeast, south, or west? Does it say positive or negative or forward or backwards? No. So we cannot solve for velocity. Our unknown is speed. So our equation, speed is equal to distance divided by time. Now let's substitute and solve. We don't know speed, so we're going to leave the s as our variable. Our distance is 54 meters, and our time is 8.5 seconds. Using a calculator, 54 divided by 8.5 is 6.35. Don't forget your units. It's going to be meters per second, and you can write it like that. Now, significant digits, we can put the answer as 6.4 meters per second. And that is how fast it was traveling. Let's do another problem, and this one is going to be a tad bit harder. So it takes you 9.5 minutes to walk with an average velocity of 1.2 meters per second to the north from the bus stop to the museum entrance. What is your displacement? Well, immediately I notice that I'm using velocity and displacement. Both of those are vector quantities, which means I need to have a direction. And there's my direction. So this problem is written very precisely. Let's start with our givens. 9.5 minutes. Now, is that a time, a distance, a displacement? Hopefully you recognize that that is a time. Your velocity is 1.2 meters per second to the north. I have to include the direction, otherwise it's not a velocity. It would just be a speed. And then displacement is what I want to know. So we've got our givens and our unknowns. But first, take notice. When I said time, when I gave you the variable of time, the units were seconds. Do I need to convert this into seconds? Yes, you do. And the way you would do that would be simply multiply it by 60 And 9.5 minutes times 60 equals 570 seconds. So this is the number we're going to use in our problem. We're not going to use the 9.5 minutes. Okay? Our formula, velocity equals displacement over time. Now, I could go ahead and rearrange this before I plug in my numbers, but I'm going to go ahead and plug in my numbers without rearranging. My velocity is 1.2. My displacement is unknown, and my time is 570 seconds. From here, I can see that you can either cross multiply or multiply both sides by 570, which is probably what I'm going to do. This crosses out, and I get 570 times 1.2 equals my displacement. That comes out to 684 is my displacement. Now, I've lost my units in the math problem, but you can always think back. This is displacement. Similar to distance, what do we measure distance and displacement in? That is meters. So my final answer is 684 meters. Or is it? If this is displacement, I have to have my direction. So my absolute final answer is my displacement is 684 meters north. So let's do one last problem. Felipe drives his car with an average velocity of 48.0 kilometers an hour to the east. How long will it take him to drive 144 kilometers on a straight highway? Let's start with our givens. Velocity of 48 kilometers per hour to the east. Velocity 48 kilometers an hour east. Now, do we need to convert this to meters per second? No. While meters per second is the preferred method or the base unit, kilometers per hour is perfectly acceptable. So we don't need to convert this. How long? What are we looking for when we're talking about how long? It could sound like a distance, like how long is it from here to there? But in physics, how long is going to be time. So time is what we do not know. How long will it take him to drive 144 kilometers? Anything with kilometers is going to be distance or displacement. And since this is a velocity, this needs to be a displacement. And the direction would be east because we know that the velocity is east. So our formula, velocity equals displacement divided by time. Let's go ahead and substitute our numbers. 48.0 equals 144 divided by time. Now, there is a shortcut to this, but I'm going to show you the algebra on how this works. Notice that the t is in the denominator. So let's multiply both sides by t. This cancels out, and we get 48.0 t equals 144. Now, what would you do from this point? Let me do a different color. You would divide both sides by 48. Those cancel out. And if we rewrite this equation, it would be t equals 144 divided by 48. If you notice, the 48 and the t have just switched places. The algebra allows us to do that, but that's a shortcut if you understand it. If not, always do it the algebra way. So t equals 144 divided by 48. And after we do that, t equals 3. Again, I've lost my units in the calculations. What did we measure? What did we use to measure time over here? Velocity was in kilometers per hour, so hour must be our units. It would take 3 hours for him to drive 144 kilometers if he's going a velocity of 48 kilometers per hour.